Alright, hello. Hope everyone is good. So how has everyone been today? How has your day been? How has your day been? How's everybody doing? Good? Cooking well? Hello, hi. So guys, today we are actually going to take and turn our attention a bit swiftly to what I would call a nice, beautiful topic that we refer to as trig or trigonometry. 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 Yes. Trigonometry. So basically we'll do a bit of revision just so that we can be on the same page where trigonometry is concerned. Well, it's very important to be on the same page where trigonometry is concerned. Trigonometry is a very nice topic, guys. It's a very beautiful topic, that one. Very nice. Very beautiful. Very exciting topic, that one. And really and truly, it is one of those topics that people can really chow a lot of marks because it has a lot, for the offering for one who wants to partake and enjoy and so forth. So with that said, trigonometry. Okay, so which grades are actually here? Because I can see that it seems like there's a beautiful mix of people in the live. Seems like there's a beautiful mix of people in the live. Tembelihle is like, no, sir, it's not a beautiful mix. It's the grade 11s that are here. Alright, so I'm just sorry. I'm gonna start just now. Hang on. Alright, so like I said, we're gonna start with trigonometry. So just to get us started, let's recap just on like what we did in grade 10 where trigonometry is concerned. Okay, in trigonometry grade 10, you guys fundamentally learned about 3 trig ratios, which were like the basic trigonometric ratios. Okay, sin, which if you write out is actually supposed to be sine, sine, not sin but sine, and then this cos, meaning cosine, and then tan, which is supposed to be like tangent. Okay, when it's fully written out. Okay, then we would usually denote or use this symbol. Now this symbol is called theta, and it's just a Greek alphabet, guys. Greek alphabet. Okay, but it basically stands for an angle. Okay, it is supposed to denote an angle. All right, so sine, cos, and tan are the 3 basic trigonometric ratios, and theta is supposed to actually represent an angle. All right, so that is basically just to get us started. So in any, I think in grade 10, in any triangle, specifically a right angled triangle, these 3 basic trigonometric ratios would basically be the following. So sine theta, we know, is actually what in a right angle triangle? It's opposite over hypotenuse. Okay, meaning in other words, it's your opposite side over your hypotenuse side. That was sine theta in a right angle triangle. Cos theta is adjacent over hypotenuse, as I'm sure you guys know very well. And then tan theta, okay, is opposite over adjacent. Okay, so these are the 3 basic trig definitions. All right, so we are just recapping on what we did in grade 10. All right, and it's very important to recap on what we did in grade 10, because at the end of the day, if we don't, then we will not be able to really get to a place where we can comprehend what it is that we do in grade 11. And plus, the concepts in grade 10 obviously are utilized in the grade 11 syllabus, so we need to know the basic trig definitions. It's no different in this particular grade 11. We need to still know the trig definitions. All right, so like I said, sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. Now I want to practicalize this. So let us say, for instance, we have ABC. This is a right angled triangle. I usually call it a RAT, right? Right angled triangle. So in this right angled triangle, what we do have is this angle, which is 90 degrees. And what we are going to do, we are just going to insert theta, all right, to represent the angle C. And then we are also going to insert another Greek alphabetical letter, which is this angle, we are going to refer to it as beta. All right, so we have theta and we have beta. So basically, here's the thing. If I ask you what is the definition of sine theta in accordance to this right angle triangle, you would obviously first and foremost look at the angle that we are referring to, and that is the angle theta. So this is the angle we are referring to. So if we say sine theta, we look at the definition. The definition of sine theta is opposite side over hypotenuse side. Now this opposite stands for the side that is opposite the angle theta. Okay, opposite side means the side that is opposite the angle theta, because they are referring to sine theta. So what we do is we go to the angle and then we ask ourselves, what side is opposite angle theta? Guys, the side that is opposite angle theta is the side AB. So we would say sine theta is equal to AB. Why AB? Because theta is opposite AB. So AB is what we refer to as the opposite side in reference to the angle theta. AB is the opposite side. Then it's the opposite side over the hypotenuse side. What is the hypotenuse side? Guys, the hypotenuse side in any right angle triangle is the side that is directly opposite the right angled that we have here. So the right angle, the 90 degrees that we have here, is always opposite the hypotenuse side. The hypotenuse is also referred to as the longest side of a right angle triangle. So we would say, therefore, sine theta is AB, because AB is the opposite side to the angle theta, over the hypotenuse side, which is AC. I hope you guys understand this. Then if I was to ask, what is cos of theta? Now, cos theta, according to the definition, is adjacent over hypotenuse. So we go to the right angle triangle again, and when we talk about adjacent side, we are talking about the side that is next to the angle theta. Adjacent means next to. The word adjacent, just in normal language in English, it means next to. So the angle theta is here. The side that is next to the angle theta is BC. Maybe someone else will say, but sir, isn't the side next to the angle theta also AC? Guys, remember that the hypotenuse side is the side that is directly opposite the 90 degrees. The side that is opposite the 90 degrees is called the hypotenuse side. So the side next to the angle theta cannot be AC. It has to be BC. So that's why we refer to BC as the adjacent side. So we would say cos theta in reference to this angle is BC over the hypotenuse side, which is AC. All right. Then what about tan theta? Tan theta, on the other hand, guys, would be equal to, so theta again is the theta angle is this one that is here. That is the angle theta. Now, by definition, what is tan theta? Tan theta is equal to the opposite side over the adjacent side. So tan theta, opposite side. What side is opposite theta? It is AB. So that is AB, which is the opposite side, the side opposite the angle we are referring to. And then the adjacent side is BC, because that is the side that is next to the angle theta. So BC would be our adjacent side. So that basically fills the definition of what tan theta is. It is opposite side over adjacent side. Mr. TK, thank you so much for the roses. I really appreciate it, and welcome in, sir. Thank you so much. Right. So guys, as we move swiftly along and very nicely okay, into just the basics of this topic, I hope you guys understand that whenever we utilize the definition, we need to ask ourselves which angle are they referring to, because it will always be in reference to that angle that we define the sides, the opposite side, the adjacent side. It's always with reference to the actual angle. So if I was to take a turn a bit here and use the same triangle, the same right angle triangle, and this time round look at the angle beta instead of looking at the angle theta. So if I was to ask what is sine beta, so once again, the definition of sine is opposite over hypotenuse. But now, since the angle we are talking about is beta and it is no longer the theta, what is the opposite side of beta? The side opposite beta is BC, right? So because we are referring to the angle beta, the side that is opposite beta is side BC. So we'd say sine beta is equal to BC, right? And then what is the hypotenuse side? The hypotenuse side does not change. It's still the side that is opposite the 90-degree angle, okay? So the hypotenuse is still the side that is opposite the 90-degree angle. So we'd say BC over AC. This is the opposite side, the side that is opposite the angle we are talking about, which is BC, over the hypotenuse side, which is AC. And remember, the hypotenuse is always the side that is opposite the right angle or the 90-degree angle. So that would be sine beta. It would be BC over AC. So we always take note of the angle that they are referring to. Let's look at cos beta. What would be cos beta, guys? Maybe you guys can let me know in the comment section. What would cos beta be? We know the definition of cos is adjacent of hypotenuse. So if you look at cos beta here, what would be cos beta in reference to the sides that we have? Cos of angle beta. What would be the cos of angle beta? Okay, we have Zamazianda saying it would be AB over AC, right? Precious as well is saying the same. A name I'd rather not call is also saying the same. Well, actually, sorry, a name I'd rather not call is saying something that is completely different from what everybody else has been saying. Okay, so Zama, you are spot on. Precious, you are spot on. So Zama and Precious are spot on. So yes, the cos of angle beta would be AB, which is the adjacent side, because remember, what's the adjacent side? It is the side that is next to the angle. And then it would be AB over AC, the hypotenuse side. So yes, you are right, it would be AB over AC. And then last but not least, what would be tan of angle beta? Tan of angle beta. Let's check if people are with us where this is concerned. What would be tan of angle beta, my amazing maths gamers? Okay, Precious is saying BC over AC. Are we sure? Remember, tan is opposite over adjacent. So in reference to this angle, opposite side over the adjacent side. Okay, Precious says over AB, so that was a correction from your side. Okay, good job. Good job. Good job, good job, good job, good job. I get you very loud and clear. So I hope we all understand that the tan of angle beta will be BC over AB, because the tan of angle beta, in reference to this angle, this is called the opposite side, and AB is called the adjacent side. So indeed, tan beta would be equal to BC over AB. Okay, right? So this is just a quick recap on the definitions, the trig definitions: sine, cos, and tan. All right. Then let's move swiftly. So this is when we are given a right angle triangle. We need to be able to utilize the basic trig definitions and be able to identify what is the ratio, okay, for a given right angle triangle. Remember that these trig definitions, okay, if you remember very clearly in grade 10, you must have all been exposed to this, that if you want to remember the trig definition of sine, remember sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. You had this mnemonic that basically would help us remember what each trig definition actually is. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and then tan is opposite over adjacent. And we need to always consider the angle that they are referring to, so that we don't ever make the mistake of basically identifying the incorrect side for a specific trig definition. Okay. Then let's move over to something else. Then we have our amazing, glorious, what do we call it? Cartesian plane. Our Cartesian plane is divided in what we refer to as, you remember our Cartesian plane, guys? Cartesian plane is divided into what we refer to as 1, 2, 3, 4. We call these 1, 2, 3, 4. We call these what exactly? We call these, someone want to tell me in the comment section, what do we call these? 1, 2, 3, 4, 4 of them. What do we refer to them? So our Cartesian plane, we divide it up into, thank you Tembelile, into quadrants. Thank you so much. In those quadrants, right, what we usually do is we utilize something called a unit circle. All right. Now, when we insert a unit circle in our Cartesian plane, we basically write or draw in what we refer to as a terminal arm. All right. And that terminal arm will make an angle, all right, with the horizontal x-axis. Well, in the first quadrant, we are obviously talking about angles that are from 0 to 90 degrees. And those angles between 0 and 90 degrees, obviously in angles between 0 and 90 degrees, we refer to those as acute angles. Okay, and obviously if we go around in an anti-clockwise direction, guys, this is the direction from this side to this side. This is the direction in which our clock does not go. Okay, in this direction we call this anti-clockwise. From 0 to 90 to 180 degrees to 270 degrees and back a full revolution 360 degrees. Hopefully we all understand that. Okay, so if we have a point here and we say, let's say this point is P, this point will be having a x coordinate and a y coordinate, all right, which is very important. Now from this origin, we call this the point of origin, to the point itself, this line is what we refer to as our terminal arm, which has the points x and y. If we were to then complete the three-dimensional shape that we have, we would obviously then have formed here in this terminal arm a right-angled triangle. This right-angled triangle, rightfully so, will have a, since this is a unit circle, from the center to the circumference of the circle, we call this a what? A radius. The distance from the center to the circumference of the circle. So we refer to this as a radius. Okay, so That's why we then refer to from here to this point of the triangle, we would refer to this as our distance of x, and then from here, which is in line with the y-axis, this would be our distance for y. X here would be positive because this represents the positive x-axis. Y would also be what? Be positive because this represents our positive y-axis. And then r, something to note is that r is always positive in all quadrants. R is always positive in all quadrants. So it doesn't matter which quadrant we are referring to. R is always positive, whatever quadrant we are referring to. So I hope you guys understand that in light of the unit circle we're talking about, this terminal arm represents a radius of the circle, but for our triangle, which is right angled, this represents the hypotenuse. The distance from the origin to where the right angled triangle has its right angle, this represents the distance of x, and then from the point P to the horizontal x-axis, this would represent the distance of y. I hope that sort of like makes sense. So therefore, in our right angled triangle, rightfully so, we can employ what we refer to, because this is a right angled triangle, we can utilize Pythagoras to basically assist us in being able to find any unknown that we may be missing, all right, in this right angle triangle. Okay, so Pythagoras then plays a role in that instance. Now guys, all right, this is just me trying to help explain to us this idea of a unit circle and why it is then that whenever we have a terminal arm in whatever quadrant, we can complete the diagram, sketch in a right angle triangle, and because we have an angle here from the horizontal x-axis to the terminal arm, that angle we know in the first quadrant will definitely be an acute angle. In other words, it will be between 0 and 90 degrees. The angle is measured in an anti-clockwise direction, okay, from 0 to 90 degrees. Hopefully you understand this, okay? Yeah, and then like I said, also note the idea of Pythagoras, okay? This is the point x and y, okay? And then obviously there's a lot of things that then we can also conclude. So the distance of r, the distance of x, the distance of y. Hopefully that makes so much sense to you. And then it also then helps us with the following understanding, which is very, very critical and important. So I then asked you guys, how many quadrants do we divide our Cartesian plane into? So you guys did establish that it's divided into 4 quadrants. So this is called the first quadrant, this is the second quadrant, the third quadrant, and then this is the fourth beautiful quadrant. Okay, now in these respective quadrants we understand something about the sign of the different trigonometric ratios. Okay, now sine theta as per our first quadrant, if we look at this right angle triangle, remember we said the definition of sine is opposite over hypotenuse. In other words, in reference to our Cartesian plane, with our x, y, and r being what we are utilizing to basically define the different sides, sine theta would be opposite over hypotenuse. In other words, in terms of y, x, and r, sine theta is y over r. And they are all positive. Remember, y here is positive, and r is always positive in all quadrants. So therefore, the trig definition for sine is a positive one. Very important to note. What about tan? Tan would be adjacent over tan will be opposite over adjacent. In other words, it will be y over x. That's also positive. Then last but not least, cos theta by definition is adjacent over hypotenuse. So that means it would be x over r, which is also positive. So what you will notice that sine, cos, and tan in the first quadrant, they are all positive. The trig ratios in the first quadrant are all beautifully positive. All of them. Sine, cos, and tan. So that is why we say in the first quadrant, all trig ratios are what? Are positive. Okay, very important. Let's move on. Let's check what would be the situation if we had our terminal arm in the second quadrant. In the second quadrant, our x-axis here is a negative x-axis. Okay? Our y value, because y here at the top is positive, would also be positive. And then our r is always positive. So if we were to look at the same trigonometric ratios, remember the angle this time, we are moving all the way from here to there. All right? Yeah. So if we're looking specifically at this particular triangle, okay, remember in this triangle, we're looking at an angle that is obtuse. Obviously, it's more than 90 degrees. But more than that, if we are looking at the specific triangle, okay, we would have what we refer to as a standard angle. But then here, internal to the triangle, we'd have a reference angle, which is very important. So let's check this out. Cos theta, sine theta, and tan theta in the second quadrant. So sine theta, for instance, will be equal to what? Still, the definition doesn't change for sine. It is opposite over hypotenuse. Sine is still opposite over hypotenuse. In other words, it's y over r. Remember, y is positive in this quadrant and r is always positive. So we still have sine being positive in the second quadrant. Then let's look at cos theta in that very same quadrant. Cos theta in this quadrant is adjacent over hypotenuse. In other words, it's negative x over r. Wow. So since it's negative x over r, that means the entire trig ratio is actually a negative one. So in the second quadrant, we can be rest assured that cos is not a positive ratio, but it is actually a negative one. And then last but not least, what about tan? Tan theta is opposite over adjacent. Opposite side, positive y. Adjacent side, negative x. Therefore, a positive divided by a negative will give us a what? A negative. So that means tan in the second quadrant is actually what? It is negative. So in the second quadrant, tan is negative. In actual fact, in the second quadrant, both cos and tan are negative. And we've actually been able to deduce that and see it when we actually utilize the irrespective sides in those particular quadrant. Okay? Hopefully that makes sense, guys, because x here is negative. And that is why both cos and tan, because they have the x which is negative in the second quadrant, would therefore make those trig ratios respectively negative. Okay? Hopefully we are still good and you guys can hear me loud and clear. So let us go and now draw the right angle triangle in the third quadrant. X in this quadrant is still negative. Y is also negative because remember we are dealing below the x-axis. That's where y is actually negative. R still retains its positivity because remember in all quadrants R is positive. So if we are going to go and write the trig ratios again here, sine in that quadrant is what, guys? Sine theta is opposite over hypotenuse. Negative y over positive r. So sine theta is equal to negative y over positive r. So that means a negative divided by a positive will obviously give us a what, guys? It will obviously give us a negative. Okay, then we come back here. What about cos? Cos will be adjacent over hypotenuse. So that means cos theta is negative x over r, which means cos is also what? Negative. And then last but not least, tan theta will be equal to negative y over negative x. Remember that in that quadrant, both the x and the y are negative values. But what does a negative divided by a negative give us? Ultimately, we get y over x, which is positive, which is why tan in that quadrant is regarded as being what? As being positive. We regard tan as being positive because a negative divided by a negative will give us a positive. Okay, so that is basically our third quadrant. In our third quadrant, only tan is positive when it comes to the basic trig ratios, but all the other ratios are actually negative. Then we look at the fourth quadrant, the last and final concluding quadrant, so that we can have a solid conceptual understanding as to why do we say so and so is positive, so and so is negative. You know, it comes from somewhere, this thing. It's not just like we just know this off by heart and that's where it ends. No, it comes. There is a root cause why it is that we say that these are positive in certain quadrants and negative in the others. So here we'll have a positive r again, because r is always positive in all quadrants. Dumsa babes, you are funny. Okay, then we have r, we have y, which is negative in this quadrant, and then x is positive in this quadrant. So like I said, we have r, which is positive, we have y, which is negative in this quadrant, and x, which is positive in this quadrant. So if we look at the angle again, look at the trig definitions. Sine here in this quadrant, sine theta will be opposite over hypotenuse. In other words, it will be negative y over r, which means in the fourth quadrant, sine is negative. Okay, then let's look at cos. Cos theta in that quadrant. What will cos theta be? Cos theta will be adjacent over hypotenuse. Adjacent meaning x, which is positive, over hypotenuse meaning r, that is positive. So that means cos is not a negative, but it is positive in the fourth quadrant. Then last but not least, what about tan? Tan theta is equal to opposite over adjacent. In other words, negative y over x. Not a negative divided by positive. It is actually a negative. So that means tan in the fourth quadrant is negative. Okay, so in summary, we now understand this thing of why we then conclude and we say the following. And this is the thing. So you know that you have what we refer to as that in the first quadrant, we say A, second quadrant, we say S, third quadrant, we say T, and then our fourth quadrant, we say C. All right. So once again, why do we say that? It's because A means all trig ratios in the first quadrant are positive. We've just discovered that by actually checking it out when we used the Y, the X, and the R to find the trig definitions. Sine was positive, tan was positive, cos was positive. This was the first quadrant. So that's why we say all trig ratios are positive in the first quadrant. It comes from this pure understanding. Okay, when we look at our X and our Y and our R for all trig ratios. So all trig ratios are positive in the first quadrant, all of them. None is negative. In the second quadrant, S stands for the fact that sine is positive. All the other trig ratios are what? Are negative. So only sine is positive in the second quadrant. Cos and tan, on the other hand, are actually negative. We need to be able to remember this. So we use this diagram, ASTC, right? And I know some people use different variety of ways to remember what this means. ASTC or CAST if you want. Some people say all students take classes, or all students take cake. Okay, I don't want to use derogatory terms on the live, but there's various ways in which people are able to remember. So all meaning all trig ratios are positive. The S meaning only sine is positive. Yes, Mokamo, so all students take chemistry. I like that. Okay, so sine is positive in the second quadrant, but all the others are negative, meaning cos and tan. Tan is the only one that is positive here, but all the other trig ratios are what? Are negative. All the basic trig definitions, sine and cos, are actually negative in this quadrant. C stands for cos is positive, whereas sine and tan are actually negative. Okay, so these all are trig positive. All trig ratios are positive. S meaning sine is the one that's positive, meaning the others are negative. Tan is the only one that's positive in this quadrant, meaning the other basic trig ratios are negative, meaning cos and sine are negative. Here, cos is positive, meaning sine and tan are negative. So we need to not forget this important, very, very important quadrant reminder of which trig ratios are positive and which ones are negative. Okay, so guys, today I'm not going to go too deep. I'm going to conclude now by looking at what we refer to as function values. All right, I'm not intending to make this long. I'm not going to go in too deep. I just want to go just on the surface and just sort of like get the introduction in. Okay, just the introduction in. Okay, so that you guys can be able to get the introductions sorted, and then you will be able to go in and do other things. But I'm sure you guys are doing this at school already, my grade 11s, which is good. But like I said, I'm just getting the introduction in. Okay, so the trig definitions, guys, we need to be 100% on point when it comes to the trig definitions. Know how to express cos, sine, and tan, using a right angle triangle. We should not be making mistakes there anymore. We should be able to identify what the opposite side is, the hypotenuse side is, the adjacent side is, in reference to an actual angle that we are given. There should be no mistakes done there. Okay, so it's very important that that happens. It's fine. If you haven't started, then I guess you guys are getting a head start then, which is fine. I'm happy about that. Mokamoso. I thought majority of you had started because I saw investigations fly, that had trig. Some of you have trig related investigations, so I thought that all of you are on that page, but I guess not. But that's fine. If you haven't started, then I guess you guys are getting a head start, which is okay as well. Okay, so for grade 11s, guys, you guys do what I refer to as function values. Okay, and these function values are basically the introduction to what we refer to as our reduction formula. So today I'm just going to do function values, and then tomorrow or another time I'll do co-function values and all the others, but today it's just important for me to look at the function values. So function values, okay, that we have are 180 minus, 180 plus, and 360 minus. All right, so if we go to our Cartesian plane, I want to show you what do we mean by 180 minus, for instance. So we have 0, we have 90, we have 180 degrees, we have 270, and back here we have 360. So I need you guys to understand the following. AR9, grade 12, I'm doing grade 12 every morning now at 5:30. In the morning, so if you want to catch grade 12, then you must join me in the mornings at 5:30. Right, you're more than welcome to join me then. And if you miss a live session, you are more than welcome to go to the YouTube channel there. I upload the live sessions that I do onto the YouTube channel so that people can watch those at their own time. So with grade 12s at the moment, we started this morning with inverse functions, okay? And we'll be doing a session every morning at 5:30, okay? Yeah. No, Ngwana, you're not late. You're not late at all. All right, not late at all. But like I said, for grade 12s, I'm having sessions in the mornings at 5:30. So that's all I can say where you guys are concerned. And closer to the time when like the exams start coming, especially for June and all of that, I'll start doing exam type questions, and we'll go through like exam type questions and look at strategies on how to answer things basically. But for now, I am teaching content, going through syllabus, okay? So that's what's important at the moment. Okay, so 0 degrees, 90, 180 to 70. Guys, so here, I need you guys to note something, that this here, so these are what we refer to as function values. 180 minus, just forget about the theta for now. 180 minus, 180 plus, 360 minus. We refer to these as function values. And these here, these theta values are acute angles. They are acute angles. These are supposed to stand for acute angles. Nothing more, nothing less. Remember, what are acute angles? Acute angles are angles that are between 0 and 90 degrees. Okay, they are between 0 and 90 degrees. Angles from 0 to 90 are what we refer to as acute angles. So when we say 180 minus, the theta value is supposed to be an acute angle, because 180 minus refers to a specific quadrant on the Cartesian plane, but only when the angle is acute does it refer to the specific quadrant we would like to speak about. So let's look at the Cartesian plane. You have 0, you have 90, you have 180, you have 270, you have 360. So when I say 180 minus, 180 minus is referring to the second quadrant. But remember, This is 180. When I say minus 180, I am going in the clockwise direction. I'm not going in the anti-clockwise direction. I'm going in the clockwise direction. But I then have to have a limit, because the angle that I am subtracting has to be an acute angle. In other words, it has to be between 0 and 90 degrees for it to fall in the second quadrant. So that's why, guys, I'm saying to you, 180 minus theta is referring to the second quadrant if and only if the angle theta is a what? Is an acute angle. So that's why 180 minus theta, we say it's speaking about the what? The second quadrant. So that is the first function value, 180 minus. And remember, theta is just, guys, a representation of an acute angle. This is a Greek alphabetic letter, meaning, in other words, they could use any other letter. It could be in English, they could use A, they could use B, they could use C, but remember, this is just representing an angle. Okay, that is what? That is acute. That is between 0 and 90 degrees. Second function value, 180 plus. Understandably so, if we are moving in this anti-clockwise direction, 180 plus, we are in the plus direction of 180 when we're going in the anti-clockwise direction. But remember, what did I say about theta? It is supposed to be an acute angle. For this to fall within this quadrant, it has to be an acute angle. This is very important, this point that I'm making, that this theta value has to be acute. Okay, so we say that 180 plus theta is referring to the third quadrant. Are we together? And then last but not least, 360 minus. So once again, 360 minus theta. Okay, this is referring to the fourth quadrant, and the angle there has to be what? Acute, guys. It has to be acute, right? So this is very important. All right, so we have three functional values in the 1 unit circle from 0 to 360. These function values are 180 minus, 180 plus, 360 minus. Now I want to show you something very quickly. So when we talk about reduction formula or reducing a trig ratio, if we have sine of 180 minus theta, okay, how do we apply the reduction formula with this function value of sine? How do we express this more accurately? So this is something that we need to go through whenever we are applying the reduction formula. Okay, 180 minus theta. So what is sine of 180 minus theta? Guys, please just bear with me. So the first thing you ask yourself is 180 minus theta is in which quadrant? That's the first thing you ask. 180 minus theta is in which quadrant? That's the question. The answer is 180 minus theta. Which quadrant is 180 minus theta? It is in second quad, right? Obviously, guys, 180 minus theta is in which quadrant? The answer is it is in the second quadrant. The follow-up question you then ask, how is the associated trig ratio in that quadrant? How is the associated trig ratio in that quad. Now guys, remember, the associated trig ratio to this function value is sine. Okay, so we asked ourselves, 180 minus theta is in which quadrant? And then we answered and we said it is in the second quadrant. The next question, how is the associated trig ratio? In other words, how is sine in that quadrant? How is sine in that quadrant? How is sine in the what? In the second quadrant. Do you guys still remember? How is sine? In other words, is sine positive or negative? If you are saying how is sine in that quadrant, you are asking, in other words, is it positive or negative in that quadrant? So if you guys remember very well, sine in the second quadrant, how is sine in the second quadrant? Okay, face down is saying sine in the second quadrant is negative. Zamazianda is saying sine in the second quadrant is positive. Mogomoso as well is saying sine in the second quadrant is positive. And guys, sine in the second quadrant is truly positive. So what we do then is we say the answer is positive. Okay, but then since we have 180 minus theta, as part of the reduction, because we have determined what is the sign of the trig ratio, sine in the second quadrant, we said it's positive. That means this 180 minus has been taken care of. So 180 minus falls away. We write down the trig ratio sign, and then we adopt the acute angle. So in other words, sine 180 minus theta is simply equal to positive. Where does the positive come from? Remember, we asked 180 minus theta is in which quadrant? We answered it is in the second quadrant. How is sine in that quadrant? Then we said it is positive. So therefore we write the answer positive. 180 minus theta falls away, and then we write sine of the acute angle, and that is our answer. Done, dusted, finished. Okay, and then 2. Let's look at another one, just one more, or 2 more or 3 more, so that we can sort of like be positively sure that we understand what we are doing here. Let's say cos of 180 minus theta. Let's see if we can apply the reduction formula again here. So sine of cos of 180 minus theta. So we ask ourselves the same question. First question, 180 minus theta is in which quadrant? The answer is 180 minus theta is in the second quadrant. Okay, that's the first thing. 180 minus theta is in the second quadrant. In the second quadrant, guys, how is cos in the second quadrant? How is cos in the second quadrant? Is it positive or negative? Remember, we asked 180 minus theta is in which quadrant? And we said 180 minus theta is in the second quadrant. How is cos in the second quadrant? And all of you guys are saying it is negative. As a result, because it is negative, that means 180 minus falls away. We take the trig ratio cos, and then we take its acute angle, which is theta. So therefore our answer is negative cos theta. That's how we reduce the function value 180 minus theta to its acute trig ratio. Okay, 3. Let's look at 10. We ask the same question. 180 minus theta is in which quadrant? I'm sure by now you guys are like, come on, sir. Like, I mean, we know where 180 minus theta is. 180 minus theta, sir, really? Could you be asking us this? This guy for real. 180 minus theta is in the second quadrant. Okay. How is tan in the second quadrant? That is the question. If it's in the second quadrant, how is tan in the second quadrant? Okay. So then we write the sign of tan in the second quadrant. It is negative, rightfully so. And then 180 minus falls away. We write down the trig ratio, and then we write down the acute angle. And guys, that's it. So what are we doing here? We are reducing the angle to its acute angle. All right, by ensuring that we ask ourselves, how is that particular function value in that specific quadrant? And then we write down the trig ratio and no longer write it in its complicated form, but as an expression of the acute angle. This is what we call, guys, reducing an angle. All right. Whether the angle was reflex, whether the angle was obtuse, but our goal for doing this is to reduce the angle so that it is having its acute angle. We reduce the trig ratio so that it has the acute angle by asking systematically the questions that I have been asking all along. Let us change it up a bit. Let's subtract sine 180 plus theta. I'm going to ask you guys the question now. Once again, 180 plus theta is in which quadrant? That's where you start. 180 plus theta is in which quadrant? You guys tell me. First, second, third, fourth. 180 plus theta is in which quadrant? 180 plus theta is in which quadrant? Precious says third. Do we agree with Precious, guys? Kebogam also does. Zama does as well. Good. Next question. In the third quadrant, how is sine, the trig ratio of sine, in the third quadrant? How is the trig ratio of sine? Is it positive or negative in the third quadrant? Okay. Do you remember, guys, which one? Yeah. So Wandile says sine is negative. Bogamoso says it's negative. Layla says it's negative. So does Zama. So yes, you guys are spot on. It's negative. So then that means 180 plus falls away. The trig ratio sign is negative. And then we write down its acute angle. And that's it. Done and dusted. That's how we reduce. That's how we apply the reduction formula. 5. Let's go. You guys are on a roll. 180 plus theta. Same question. 180 plus theta is in which quadrant? You guys know the answer. How is cos? You guys know the answer. You write down the sine, you write down the cos, you write down its acute angle because the 180 plus falls away. You guys get this flow of what we're doing every single time. 180 plus is in which quadrant? How is the sign of cos in that quadrant? You fall away 180 plus, we assume the the acute angle, and the cos tags along in there. So all in all, we have what? A negative cos of theta. Okay. 6 tan 180 plus theta. 180 plus theta is in which quadrant? Once again, we answer that question. How is tan? We answer that question. We write down the sign. We write down the trig ratio. The 180 plus falls away. We assume the acute angle. You see? So you guys get this. Yes. Positive tan of theta. Thank you so much, guys. You guys are flowing with this very nicely. Okay. And then I just want to look at the last function value. And then I'll call it a night for now until further notice, guys. Okay. sine 360 minus theta. Sine 360 minus theta. Which quadrant is 360 minus theta? You see, which quadrant is 360 minus theta? Okay, Karabo says fourth quadrant. And very true. Sine, how is sine in that quadrant? So I see Karabo answered the follow-up question as well. How is sine in that fourth quadrant? You guys are spot on. It is in the fourth quadrant. How is sine in that fourth quadrant? One delay, you are true, it's negative. Karabo also said it's negative. Okay. Then what happens? Bogamo also is spot on. It's definitely negative. Sky, you have negative. Then 360 minus falls away. We assume sine. We take the acute angle. And that's done and dusted. We finished. Okay. 8 sine. We are done. Now we move on to the next trig ratio, which is not sine, but it is cos. Cos of 360 minus theta. We do the same thing. 360 minus theta is in which quadrant? How is cos? 360 minus theta is in which quadrant? It's in the fourth. It's negative. It's in the fourth quadrant. 360 minus theta is in the fourth quadrant. How is cos in the fourth quadrant? Hope you guys remember that in the fourth quadrant, cos is one of those trig ratios that seems to be sweetly positive. Okay, so therefore we know it's positive cos. 360 minus falls away. It's cos theta. Guys, please know the trig ratios that are positive and which ones are negative in each quadrant. Because once you master this, guys, that's where your trig ease comes. Once you master all trig ratios are positive in the first quadrant, sine is the only one that is positive as far as the trig definitions. In grade 10, you guys did reciprocals. That's the reciprocal of sine, which is cosec, which would also be positive here. The reciprocal of tan, which is cot, which would also be positive here. The reciprocal of cos, which is sec, which would also be positive here. But the reciprocal trig ratios were a grade 10 phenomena, and they were actually limited to that grade. In grade 11, I mean, there's no serious concern about that, as well as in grade 12, but you just need to know and continue to understand and remember those reciprocal trig ratios. Okay, but anyways, our primary focus is on the basic trig ratios, which is very key. So sine positive here, all others negative. Tan positive here, all other basic trig ratios, sine and cos, are negative. Here cos is positive, all other trig ratios, sine and tan, are negative. Once you know that and you've mastered that, then that makes it easy for you to answer these questions. And really and truly, it needs to also become something that we become very affluent in answering and doing without too much thought and without making silly mistakes. We can't make silly mistakes, guys, when these are concerned, because the minute you get the sign wrong, hey, that's a problem. Okay. Then tan, which is the last trig ratio that has to do with function values, 360 minus theta. Okay, you guys wrote the answer. Thank you, Zama. All right. Remember, guys, even if the positive sign is not there for cos, remember, its absence also means it's present. Okay, that's another thing with positive. Okay, but with negative, you have to show that negative is negative. But with positive, its absence does mean positive is present. Okay. Tan 360 minus theta, definitely 360 minus theta in the fourth quadrant. Tan in that quadrant is negative, so the answer is negative tan of theta. Guys, I'm going to hold it right there for tonight. Okay. I don't want to go too far. So just quickly to recap, we looked at the definitions from grade 10 syllabus: sine, cos, and tan. What are the basic trig definitions for sine? The fact that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. We then looked at a particular right angle triangle, looked at the fact that depending on the angle we are referring to, the opposite side and the adjacent side changes, but the hypotenuse side never changes because the hypotenuse is always opposite 90 degrees. If I'm referring to this angle, then this is called the adjacent side, this is the opposite side. But if I'm referring to this angle at the bottom here, which is theta, this is the opposite side and this is the adjacent side. So the opposite and the adjacent side will always change in accordance to the angle that I'm referring to. Okay, and that's very important. Knowing the definitions is important. SOHCAHTOA helps us to remember the definitions without much thought, because we know sine is always opposite over hypotenuse, cos is always adjacent over hypotenuse, and tan is opposite over adjacent. Then if we look at the Cartesian plane, we looked at how do we actually understand, how is it that we get an understanding that in the first quadrant, sine, cos, and tan are all positive? How do we get an understanding that in the second quadrant, it is sine that is positive, but the other ones are negative? And so it goes. We looked at this unit circle. We looked at how we derive our understanding of why in each quadrant we have a positive and negative signs for different trigonometric ratios. And then we looked at cast, or all students take chemistry, the ASTC rule, in other words, where we know that all trig ratios are positive here, sine is positive here, but the others are negative, cos and tan. Here tan is positive, sine and cos are negative, here cos is positive, whereas the tan and the sine are negative. Then we looked at function values, guys. 180 minus, 360 plus, and 180 minus, 180 plus, and 360 minus, because these are function values that exist in the second, the third, and the fourth quadrant respectively. How then do we reduce these? Asking ourselves like 3 fundamental questions that help us to be able to reduce a function value to a trig ratio with an acute angle. All right. And that basically was our introduction to the trigonometry. We will develop this as we go along, guys, but that is the introduction lesson, and I hope it was really fruitful. And I'll see you guys again next time. Thank you.